important note is that sometimes you'll see a problem where we have, let's say, like something goes from, I don't know, okay, here's a good one. So let's say x is greater than 0. Okay, well actually let's use our s example, right? Remember from the beginning our side length is greater than 0. So how would we write this in interval notation? So that means, well, if we switch it around, that means 0 is less than x, okay, or less than s, that is. Okay, so we write down this left endpoint, and then what's the other thing? We don't have another endpoint, so that implies that this s doesn't have an upper bound. It isn't restricted above by anything. So that means it can go all the way to infinity. Okay? Well, that might look a little bit funny, and it does. But now I'll show you. The important point is to say that whenever we have infinity or negative infinity or negative infinity, you always use rounded braces or parentheses here, okay? Because there is no definite value, so it can't include that endpoint because there is none to speak of. Okay, so we're just going to have a rounded brace there automatically, and on the left side, because we don't have or equals to, that would also be a rounded brace. Okay? Alright, so here's an example. We're going to express the interval depicted on this number line in interval notation. Okay? So one thing to note, you might see it's a little bit funny here, but here we have what's called, at -2, we have what's called a closed dot, and the same thing at -1, but at 3, right here, we have what's called an open dot, okay? So let me tell you what those mean. So a closed dot like this, so this means a closed dot, that means that it includes that point. Includes, in this case, like an endpoint, okay? Whereas the open dot means it excludes it, so does not include endpoint, okay? Alrighty, so this will tell us what kind of braces or brackets we should use, okay? So for this one, we have, well, it's a little bit funny because we have like two separate intervals here, right? Because we make this leap in between -2 and -1, and our interval doesn't include that. So we'll address that later on in the problem, okay? So let's just work with each of these like segments, these blue lines here separately. So let's look at this first one. So we have -2 is the upper bound here, like that. And then the arrow implies that there is no lower bound. There's no lower limit or anything. So we have negative infinity. It can go all the way to negative infinity. So when we see something like that, remember when we see infinity or negative infinity, we always have a rounded brace or bracket or parenthesis there, okay? And then we see at -2, we have a closed dot, which means it includes the endpoint, which means it's kind of equivalent to or equals to. So we have a square bracket right here, okay? So that takes care of this blue line here. Now let's look at this thing, this little mini interval, okay? So let's deal with that separately. So we have -1 is our left one, and 3 is the upper one, okay? So for 3, we have an open dot, which means we don't include the endpoint, which is kind of like the where our or equals to is absent. There's none there, okay? So we have a rounded brace here. Okay, whereas at -1, we have a closed dot, which includes the endpoint, meaning that we have a square bracket there, or square brace. Okay, so now the thing is, so now we're done with each one of those individually, and now we need to express this as an entire, a unified interval, okay, using interval notation. So in this case, when we have like two kind of separated intervals, but we want them to be one at the same time, what you do is you just stick it looks like a U sign, and it is, kind of. It just means union of two intervals, okay? Two things together, all right? So that just, it connects our intervals, our mini ones. Connects into a single unit, or a single interval, we could say, okay? All right, so now let's go over, we can examine the domain and range of our toolkit functions, okay? So here we're going to, toolkit functions. Hold on here. Okay, there we are. So this is going to get pretty interesting, actually, I think, because we're going to look at each of our functions that we've learned before, or at least previewed in the last section, and we're going to see, okay, what are the domain and range of each one of those, okay? So let's start with constant function. So a constant function, and this is represented by f of x is equal to c when c is a constant. That means like a number like 2 or 3 or anything like that, okay? So what does this look like, first of all? So our constant function, here's x and y. Let's say c is here. So this is the line y is equal to c, or c is equal to f of x, okay? So it's a horizontal line, basically, right? So that means that there are no restrictions on x. We can go as far left and as far right as we want to. So that means our domain is going to be negative infinity all the way up to positive infinity, okay? The whole like number line on x, right? And then range, what can our y values be, or what are our output values? And whatever, let's look at the equation actually, the formula here. This is interesting because it means whenever you plug in any x, we're still going to get out that same constant, whether it be like 2 or something. So even if you plug in a negative 71, you're still going to get out the same height, 2, 2, 2. Everything you plug in, you're just going to get 2. So in this case, though, we're just working with c, so we're just going to say this just includes c. And we use the square brackets because we're just describing one point here, right? Or one value, okay? So the range here is just going to be c because it's a constant function. All right, so now let's examine the identity function. Identity function, and this is represented by f of x is equal to x, okay? So that means whatever our input is, our output's going to be exactly the same. It doesn't change anything at all, okay? So what does this one look like? We have our x and our y, okay? So that means when you plug in a 1, we're just going to get 1. So that'll be like this point here. When you plug in a 2, you get 2. Plug in a 3, you get 3. Okay, so we basically just have a line with a slope of 1, okay? And that crosses through the origin, which is 0, 0. So in this case, we have a line, like I said. It goes up and down and everything, and it's a slanted line, so it's not like a constant horizontal one or anything. So there are no restrictions on x or y, so that just means that our domain is going to be from negative infinity to infinity, as is our range. It'll go down all the way to negative infinity and all the way up, continuing toward positive infinity. Okay? All right, so now for a little bit more complicated ones, we have quadratic functions. Which are represented by f of x is equal to x squared, okay? So the thing is here, this is what the graph looks like. So we have our x and our y, and it looks like basically like a U kind of thing, okay? And it crosses at 0, 0 down here, and it continues up to the left and up to the right to infinity, basically. So our domain, first of all, is x can be anything. There are no restrictions on x, so we have negative infinity all the way up to infinity. But our range, that's interesting, because if we look at the graph, we can automatically tell what our range is. And if you look at the formula for our function, you can tell what it should be anyways, because anything squared, any number squared, is going to be positive, right? Or at least 0. It's not going to be negative, okay? So this is definitely going to be greater than or equal to 0. The only time it's equal to 0 is if x is equal to 0, right here, right? So that means that our range must be, including 0, it goes up to positive infinity, okay? All right, now let's look at the next kind. We have a cubic function, which is f of x is equal to x cubed. This is kind of like our volume of a cube thing, or yeah, volume of a cube. And so here, this one's kind of unique. This is the S shape, right? So we have something that looks like this and like that, right? So we see that, well, x can be anything, and even though it looks like it's kind of narrow and it might like stop like this or something, no, it just continues on. So domain's going to be negative infinity to infinity, as is our range. Okay, negative infinity up to infinity. Nothing super exciting. Alrighty, now we'll go on to the reciprocal function. Reciprocal, there we go. So this would be f of x is equal to 1 over x. So whatever you plug in for your input, your output is going to be 1 over whatever you plugged in. So this one here, this is a little bit different. So we have, here's our x and y. So this is going to look like this. It's kind of like two outwards facing like horseshoes or U's kind of thing, okay? The only thing is that x, if we plug in x equals 0, that gives us an answer that's undefined. So that means that our domain cannot include x, because otherwise our function's undefined and we can't do anything with it. So domain, in order to work around x being 0, what we would do is instead of saying negative infinity to infinity, we just kind of chop it off at 0 here. The rounded bracket again means we don't include that endpoint, right? And we just, I don't know what the term is, but we put union with the other interval 0 up to positive infinity. So here, see this whole thing here, what we did with the rounded brackets and the u connecting the intervals, we just kind of jumped over the point 0 in our domain, okay? And then our range, on the other hand, well, if x can't equal 0, then f of x, this whole thing, this fraction here is never going to equal 0, right? Even if you have a non-zero number that you're plugging in, f of x can never equal 0. So the same thing is going to hold for the range as well. So negative infinity up to 0, not including that endpoint, and then 0 up to infinity as well. Okay, so now let's look at reciprocal squared. Reciprocal squared function. Okay, and this is exactly what it sounds like, 1 over x squared. Okay, so it's going to look basically like what we have up here, except for it's going to become more steep. Okay, and the left part is going to flip up to the top because now it's squared, so it has to be positive. Our answer is. Okay, so in this sense, our domain is going to be the exact same. It didn't really change because you still can't plug in x equals 0, right? But you can plug in everything else. Okay, so we have something like this, 0 up to infinity. And our range is now different, right? Because now we can't even, it can't be negative down here, right? Because we have things being squared, our x being squared. So in this case, what we're going to have now is just 0 up to infinity for our range. Okay, we're getting to the end. So we have cube root now. Okay, so this is f of x is equal to the cube root of x. Okay, and this one looks like the following. It is an s, but it's a sideways one this time. So something like that. Okay, so we can kind of see here that the domain is going to be unrestricted. So that means negative infinity to in positive infinity. And our range is also going to be the same. Okay. Alrighty, now we have our square root, which is arguably more commonly seen, just in problems in general. So square root f of x is equal to the square root of x. Okay, and this guy looks like the following. So we have our x and our y. Starts at 0, 0, and it goes up like this, kind of like a swoosh to the right. Okay, so this is going to be our domain, because we can't. The thing is, we can't plug in a negative x or a negative number for our x, because you can't take the square root of a negative number. So that means it has to start at 0 and go all the way up to infinity. And the same thing goes for our range, because our f of x, if x can't equal a negative number, and we're never going to take the square root of a negative number, so you can never get a negative answer kind of thing, because we just have a positive 1 out in front there. So anyways, so that just means that our range is going to be exactly the same, 0 up to infinity with the square bracket there, because we can plug in 0. The square root of 0 is 0. Alrighty, now for the last graph, the last toolkit function here. So absolute value function. Okay, so this is denoted as f of x is equal to this thing. Okay, so if we look at that, this is basically saying the same thing as we saw before with the x as this line here, except for now, instead, when we plug in a negative x, then it flips up and becomes positive. Okay, so we have kind of like a v thing going on. Alright, so the domain here, there's no restriction on x. You can plug in anything you want. So this is negative infinity to infinity. But the range, on the other hand, it goes from 0, inclusive, right, all the way up to positive infinity. Okay? Now, one last important thing to go over are called piecewise functions, okay? Piecewise functions. So what are these? Let me define it for you. This is when we have more than one possible formula to use or to represent our function, depending upon the domain, the part of the domain that is, that an input lies in. The input lies in. Okay, so what I mean by this is the general format of a piecewise function is the following. So let's say we have a function, f of x is equal to, and usually you see something like this, and we have like formula 1 is stated here. So you'll see something in terms of your x, in terms of your independent variable, and then you have if x is something, something, something. So then you have listed the domain that you need to use formula 1, okay? So I won't write too much here. Formula 1, okay? And then here you would have the next one, for the next formula that you could use, formula 2, and then you would have listed domain that you need to use this formula as opposed to all the other ones, okay, that are listed. Formula 2, and then it just goes on and on for however many pieces of your function you have. Okay, so let's do a quick example of this just to exemplify what's going on here. Alright, so we have the problem, a museum charges $5 per person for a guided tour with a group of 1 to 9 people, or a fixed $50 fee for 10 or more people in the group. Set up a function relating the number of people n to the cost c. Okay, so cost in this case depends on the number of people, right? So c of n is going to be our function. And if we look at it, let's read through the first part again. So c, our cost, can be represented as, it says $5 per person. So that means 5 times n with a group of 1 to 9 people. So I'll just write it in normal like English kind of thing. And that just means like when 1 to 9 people in your group, okay? But we have a fixed fee of $50. So C is equal to $50 when we have 10 or more people, right? So we basically almost kind of wrote out our piecewise function already. We just need to write it in formal terms. So this would just be C of n is equal to, and then we write our fancy like bracket thing. And then we have 5n is our first formula. And what's our domain going to be? So people is represented by n, right? That like they told us in the problem. So this is when n goes from 1 to 9, inclusive. Inclusive meaning, that just means like you include the endpoints. So we can write 5 times n, and I'll just say if, usually they write if for your domain. It doesn't really matter that much. Anyways, so this makes sense. So because we have our cost is 5 times n if n is between 1 and 9 inclusive. Okay, so including the 1 and the 9. All right, or we have our second formula is it just equals 50 if we have that n is greater than 9. Greater than 9 meaning 10 in this case, right? So that would pretty much be it, right? So this is all. We just wrote our piecewise function, okay? So that was pretty simple. And let me just show you like what the graph would look like because it would just come in, as the title already kind of gives it away, but it would come in pieces, okay? So let's say this is our n, and this is our c of n, okay? So it basically looks something like this. Let's say this is 10, 20, 30, 40, 50, 10, 20, 30, 40, 50, okay? So 50 is up here, and this is 10, okay? So from 1 to 9, we have 5 times n. So we'd start at 5, and we'd end up at 9 times, so that would be 45. So somewhere up here, right, a closed dot. So we'd actually have like a straight line going on, okay? Because we have a set slope, which is 5. And then at 9, it switches over, and non-inclusive, we start at 50. So that would be an open dot there. And we just have a constant line of 50. That means after your group is greater than 10 people, then for 12 people, it'd still be $50. For 25 people, it'd still be $50. So that's why we have this constant piece up here. And then here we had a line with a slope of 5 from that first formula. Okay? Alrighty. So that wraps up our video, our concepts video on domain and range. I hope that helps, and I'll talk to you in the practice problems video if you watch.